finish off 8.3 by looking at some more questions where we have expressions involving logarithms. So I wrote on the board, Thursday, March 30 would be our next exam. So I think after this lesson, which is Wednesday, you'll have a class Monday, Wednesday, Friday next week. And we should finish off the rest of this chapter by next Friday. And then you'll have a quiz first before your test on Thursday the 30th. So probably on that Friday, you'll have a Chapter 8 quiz, and then that will give us the Tuesday to go through it, as well as your Chapter 7 quiz before you write your test on Thursday. Okay? So I'll put that date for the quiz up there as well, but it'll likely be Friday, a week from this coming Friday. Okay, so the human ear is sensitive to a large range of sound intensities. Scientists have found that the sensation of loudness can be described using a logarithmic scale. The intensity level beta in decibels of a sound is defined as beta equals 10 times log of I over I sub 0, where I is the intensity of the sound in watts per square meter, and I sub 0 is 10 to the negative 12 in the same unit. That corresponds to the faintest sound that can be heard by a person of normal hearing. Audiologists recommend that people should wear hearing protection if the sound level exceeds 85 decibels. The maximum volume setting on a portable media player with headphones is about 110 decibels. How many times as intense as the sound of the chainsaw is the sound of the volume setting of the portable media player? How many times as intense? So we have to do this by using division, okay? Because if I say that Miriam is 3 times as smart as me, right, that would mean that if you take her IQ and divide by my IQ, you get 3 times as intelligent, right? So to get what that is, to get that 3, you divide the 2 IQs. So we're going to have to use division here. But remember that the division law of logs involves subtracting the individual logs. So originally we're going to set this up as a subtraction statement. Okay, so here we go. We are told at the top that B beta, which refers to the intensity level of the sound in decibels, and we are told that that can be found by going 10 times the log of I over I sub 0. 10 times the log of I over I sub 0. Now we have 2 sounds here that we are comparing. One of them being, we want to know how many times as intense as the sound of the chainsaw is the maximum volume setting of the portable media player. So those are the 2 that we're going to compare, right? The sound intensity of the chainsaw and the sound intensity of the media player. So the first one we'll say is beta sub 1. So that'll be 10. Whoa, let me try that again. Beta sub 1 will equal 10 times the log of I sub 1 over I sub 0. And then we're going to have the second sound, which we'll say is beta sub 2. That'll be 10 times the log of I sub 2 over I sub 0. So if beta sub 1 corresponds to the sound of the chainsaw and beta sub 2 corresponds to the sound of the media player is louder than the chainsaw. So as I said, we're going to set up a subtraction equation here because that leads to division, right? The quotient law of logs say if you have the difference between two individual logs, you can combine them into one log by taking the quotient of the two arguments, keeping the base the same. So I'm going to go b sub 2 take away b sub 1. B sub 2 is defined as 10 log I sub 2 over I sub 0. And we need to subtract b sub 1, which is 10 log I sub 1 over I sub 0. And again, the reason I'm setting up a subtraction statement is because when you're subtracting logs with the same base, you can combine them into one statement by using the quotient law. So that's going to introduce the quotient part, where we can determine how much more intense one sound is compared to the other, how many times more intense. Right? So this equation that we've written here, we can simplify it on the right by taking out a common factor of 10, and that'll leave us with log I sub 2 over I sub 0 minus log I sub 1 over I sub 0. And now this is the part inside those big square brackets. This is the part that we will put together using the quotient law. So I'll have b sub 2 minus b sub 1 equals 10 times the log of I sub 2 over I sub 0 divided by I sub 1 over I sub 0. And so in the square brackets, you're dividing one rational expression by another. We know that to divide by a rational, you multiply by the reciprocal. This will be 10 log of I sub 2 over I sub 0 times the reciprocal, which will be I sub 0 over I sub 1. And now the I sub 0s will cancel. So we are left with b sub 2 minus b sub 1 equaling 10 log I sub 2 over I sub 1. And basically, we want to solve for the argument. We want to know what I sub 2 divided by I sub 1 is. That'll be how many times more intense the sound level of the media player is compared to the sound level of the chainsaw. Now, we can put our values of b sub 2 minus b sub 1 in there, and I could have done it earlier. It doesn't matter. But the decibel level for the headphones is 110. The decibel level for the chainsaw is 85. So this left side will become 110 minus 85. And again, I could have done that earlier. Could have done it at the start. It doesn't matter. But this is going to allow us to, again, solve for I sub 2 over I sub 1. So 110 take away 85 is 25. And if we want to get the I sub 2 over I sub 1 by itself, we would do that by first dividing the 10 on both sides. So 2.5 is what we'll get on the left side because it's 25 divided by 10. And that will equal the log of, again, I sub 2 over I sub 1. And now we will convert from logarithmic to exponential. Remember, this is a common log. No base indicated means it's base 10. So when you convert from logarithmic to exponential, you start with the base and cycle through. Remember, the bases are the same in either form, so it'll be 10 to the power 2.5 equals I sub 2 over I sub 1. And so our answer is whatever 10 to the power 2.5 is. That's how many times more intense the sound level of the media player is compared to the sound level of the chainsaw. So approximately 316 times more intense. So again, the key to this is realizing that if you want to know how many times more intense the level of sound is of the media player compared to the chainsaw, you get that by division. And in order to get division, you have to first set up a subtraction statement involving logs. Because the quotient law says if you have the difference between two logs with the same base, you can combine them using that quotient law. And it becomes one log, but the argument will be the quotient of the two arguments. Yes? This step right here, that's the quotient law of logs. If you have the log of 10 minus the log of 5, you can say that's the log of 10 divided by 5. That's the quotient law. Okay? All right. So this next one is similar. The human ear is sensitive to a large range. It's the same lead up. The only difference is now we're doing part B that says sounds that are at most 100 times as intense as a whisper are considered safe, no matter how long or how often you hear them. So the sound level of a whisper is 20 decibels. What sound level in decibels is considered safe no matter how long it lasts? So that will be a sound level that corresponds to an intensity that is 100 times as intense as the whisper. So the formula that we developed on the previous page was that B sub 2 minus B sub 1 equaled 10 times the log of I sub 2 over I sub 1. That is the formula that we developed on the previous question. Right? Now, in this case here, you want to know what sound level, so you want to know what B sub 2 is, such that it is 100,000 times as intense as the sound level of a whisper, which is 20 decibels. B sub 1 will be 20 decibels. And we are told that the one sound is 100,000 times as intense as the other. So that 100,000 represents the ratio of I sub 2 over I sub 1. On the previous question, we found out how many times more intense the sound level of the media player was compared to the sound level of the chainsaw. We found that out. We got 316 approximately. That was what I sub 2 over I sub 1 equaled. In this case, we're given that number. The sounds that are at most 100,000 times as intense as a whisper are considered safe. What is that decibel level of that sound if the whisper has a decibel level of 20 decibels? So we need to solve for B sub 2, which is fairly straightforward because we can calculate what the right side is. That log of 100,000, that's a common log. You can do it in your calculator. I think that is 5. That's asking 10 to what power is 100,000. Yes, it's 5. So it's 10 times 5, which is 50. 10 times the log of 100,000, the log of 100,000 is 5. And when you add the 20 to both sides, B sub 2 is 70 decibels. So a sound level of 70 decibels, no matter how often you hear it, no matter how long you hear it, should be safe for your ears. That's what that tells us. Okay? So the pH scale is also logarithmic. It's used to measure the acidity or alkalinity of a solution. The pH of a solution is defined by, and there again, there's a log equation. pH can be found by going negative log times H positive, where H positive is the hydrogen ion concentration in moles per liter. A neutral solution, such as pure water, has a pH of 7. If the pH is less than 7, it means it's more acidic. pH is greater than 7 or more alkaline. The closer the pH is to 0, the more acidic the solution would be. So the lower the number, the more acidic, the higher number, the more alkaline. A common ingredient in cola drinks is phosphoric acid, the same ingredient found in many rust removers. A cola drink has a pH of 2.5, so it's closer to 0, more acidic. Milk has a pH of 6.6. How many times as acidic as milk is the cola drink? So this will be similar to the one we just did with the sound intensities. We wanted to know in part A of the previous question, how many times more intense was the one sound compared to the other? So to determine that, at one point you're going to have to doing some division. But it's the quotient law of logs that leads us into the division. So just like the last question in part A, we're going to have a subtraction statement and then use the quotient law to write it as a division. And it starts with the equation that we're given, that pH equals negative log of H positive. And again, we're going to have two different pH that we're going to be talking about. We're going to have pH 2, which will be the one that's more acidic. We want to know how many times more acidic the cola is compared to the milk. So pH 2 will be negative log of H positive 2, and pH 1, which will be the pH of the milk, because it is less acidic, will be negative log H positive 1. And again, we need to write a subtraction statement. So it leads into division when we use the quotient law of logarithms. So it'll be pH2 minus pH1. That'll be negative log of H positive 2 minus negative log of H positive 1. On part A of the previous question, we waited till the end to put in our two pHs. I said we could have done it at the start, so let's do it at the start. Again, we want to know how many times more acidic the cola is compared to the milk, so the pH 2 will be the one that's more acidic, which means has a pH closer to 0. So it'll be 2.5 take away 6.6. And on the right side here, you have a minus minus, that's going to become a plus positive. And then probably what we'll do here is, well, on the left side, 2.5 take away 4.6 is negative 4.1. And on the right side, if we rearrange those terms to put the positive 1 first, just rearrange them. Now we'll introduce our quotient law. So this will be the log of H positive 1 over H positive 2. Now, Again, we will convert from logarithmic to exponential. And if you do that, you'll have 10 to the negative 4.1 equals h positive 1 over h positive 2. But you have to realize that we need to do the reciprocal of this, because we want to know what the ratio of h positive 2 over h positive 1 is, right? Because we need to do pH2 minus pH1. So we're actually going to have to do the reciprocal of this, which is like raising both sides to the power negative 1. And so that will now give us 10 to the power positive 4.1 equaling the ratio of h positive 2 over h positive 1. So our answer will be whatever 10 to the power 4.1 becomes. So there's quite a difference there in levels of acidity. 12,589.3 times more acidic. So the cola is 12,589.3 times more acidic than milk. All right? Part B. Let me cut and paste that to a new page. Or do you have it as a new page on your booklet on the next page? No? Okay. So I'll just create a new page here. So an apple is 5 times as acidic as a pear. Pear has a pH of 3.8. Then what is the pH of the apple? Right? So basically, if we look back at kind of the equation that we more or less developed here, so this 4.1 came by subtracting the two pH levels. So if we wrote a general equation for this scenario, a general equation, it would be 10 to the power pH2 minus pH1 equals H positive 2 over H positive 1. So that's a formula that we more or less developed. Okay, this 4.1 here, this exponent came from subtracting the two pHs. So we more or less developed a formula that we can use now for any questions involving pH when you're comparing acidity or you're comparing alkalinity. So this is the formula that we're going to use for this next question. 10 to the power pH2 minus pH1 equals H positive 2 over H positive 1. So we are told that the apple is 5 times as acidic as the pear. It is more acidic. right? And the ratio of H positive 2 over H positive 1, which is on the previous question, what we solve for to get how many times more acidic the cola drink was compared to the milk. In this case, we're given how many times more acidic the apple is compared to the pear. We need to find out what the pH of the apple is. So again, the apple is more acidic than the pear. So that'll be pH 1 in this case. Yeah, that'll be pH 1. So it'll be 10 to the power of 3.8 minus pH 1. So it says that the pear is a pH of 3.8. So we're finding pH 1, which is the pH of an apple. And it should be closer to 0 because it's more acidic. Now, if we go through this and we get a let's say a negative value, that just means that we had these two in the wrong order. Okay, so we'll find out here. We'll find out here, and we'll find out by converting this from exponential to logarithmic. This exponential function has a base of 10, so when you write it as a log, it'll be base 10. And remember, starting with the base and cycling through tells you what order the other pieces are in. So after the base 10, the next thing you would write is the 5. And after that, it will be the last piece, which is 3.8 minus pH 1. And log base 10 of 5, you can evaluate that using the change of base identity. It's log 5 over log 10. By using the change of base identity, you have written these with a base of 10. So you can evaluate on the calculator. But the denominator will just be 1. Log of 10 is 1 because remember, there's no base indicated. That means they're both base 10. That's what allows you to use just the log key on the calculator. And so the denominator is really saying 10 to what power is 10? And the answer is 1. Or if you take what I just wrote with the base in there and use the change of base identity again, it'd be log 10 over log 10. 1. Okay? So really, it's just the log of 5 over 1, or the log of 5, which is what you would have gotten had you, if you have the newer operating system that allows you to put logs with any base in there, log base 10 of 5. Well, I guess that's still just log 5 in the calculator. It's the same thing. Either way, you'll get 0.699 if I round to 3 decimal places. So the left side works out to be 0.699, and that equals 3.8. Take away pH 1. When you subtract the 3.8 from both sides, you're going to get a negative value, negative 3.1, and that's what negative pH 1 is, and so divide both sides by negative 1, and the pH of the apple is 3.1, which we needed it closer to 0. If it's more acidic, it's closer to 0, and 3.1 is closer to 0 than 3.8, so that tells us that we set up the original expression correctly. The 3.8 minus pH 1 was the correct way to set it up. Okay? All right. So for practice, you can work on page 402, number 13, 15 through 17, 19, C, and D. we'll post the solutions on Google Classroom so you can check your answers. So again, we'll spend a couple days finishing off, I guess next 3 days finishing off part 8.3. Probably have a quiz on chapter 8 on Friday. And then on Tuesday, we'll go through the quiz for chapter 7 and 8. And then your test will be Thursday. You'll also send out the review. I'll have that for the next class. So if you want to start working on that, you can. The unit review. Yes, ma'am. Yeah. Okay.